All right, everyone. So problem number one on basically this is, by the way, a second version of your 176 sample final. So the first problem states to evaluate the following indefinite integral, which reads as the integral of -4t e to the t dt. So to solve this problem, we need to use integration by parts. And the formula for integration by parts says that if you have the integral in the form of u dv, this is equal to u times v minus the integral of v du. So what I need to do is to find my u and dv inside of this integral. So in this problem, what I can do first, by the way, just to make my life a little easier, I could pull the constant multiple out, right? So instead of saying I have -4t et dt, I could pull the -4 out and just have the integral of t e to the t dt. So now this makes it easier for me. I could say let u be equals to t and let dv be e to the t dt. Now, for u, we need to find its derivative, right? So du is going to equal to the derivative of 1, which is, sorry, the derivative of t, which is 1. So this would give us 1 dt, or just simply dt. And the antiderivative of e to the t dt is going to be my v, which is e to the t. So by integration by parts, we're going to have the -4 on the outside, right? I'll put this big bracket here. We'll have u times v, so that's t e to the t minus the integral of v times du. So you'll get e to the t times e to the t dt. Now, when you look at your integral, you just see that you have e to the t dt again, and you will take the antiderivative of e to the t, which is e to the t. So this will give us -4 in brackets t e to the t minus e to the t, close brackets, and then put a plus c, right? Your arbitrary constant. And then you could just multiply the -4 in, right? So you get -4 t e to the t minus when I take -4 and I multiply it by the negative e to the t, that becomes a +4 e to the t plus c. And that would be my answer to problem number 1.